Okay, good day everyone around the world. My name is Lukáš Plíštěna and I would like to welcome you to today's webinar, which will deal with the most important application of nanofibers so far. And it is nanofibers for air filters. I would also like to welcome you to the next webinar, which will be at the end of January, and that will deal with electrospinning for water and energy membranes. Today, we will have two speakers from the Focus company based in Hong Kong, and I will introduce them in a few minutes. First of all, I would like to introduce my colleague, Kateřina Rubáčková, who will give a short speech about our company, Elmarco, who is actually the organizer of this webinar. So, Kateřina, please.
Yeah, thank you. So welcome you everybody again, and thank you for finding your time in maybe for some of you very hectic days before Christmas. It's my pleasure to repeat again some facts about Elmarco, because Elmarco is the organizer. So just remind you, or for somebody who is new to our webinars, just repeat or explain what we are. So Elmarco is a global company producing and delivering, selling Nanos Spider technology. Is the technology that offers the production of nanofibers by method that where we're using a wire as an electrode. We are globally located already for more than 20 years in the market, and having more than 250 installations over the world. How does the technology look like? So as I mentioned, we work with a wire. Wire is our electrode. We are bringing a polymeric solution on the top of the wire by the distributing element. And the electrospinning is taking place from the surface of this wire towards the top electrode, where in between there's a substrate moving. And a substrate can be anything starting from paper, foil, or any non-woven textile, basically anything which can be rolled through the spinning chamber. So nanofibers are basically deposited on the surface of such a moving substrate and are collected on the winder, again in the form of the rolls. Next slide. So this is the portfolio of our machineries that we are currently distributing, starting from small scale laboratory equipment, leading to the, let's say, industrial solution. So we are bringing to the market not only the, let's say, Nanos Spider, which is our, let's say, main part, but also the technology as the total, including the peripherals, which are forming actually the total, let's say, production line for the fibers. This is a summary of applications, which are, I think, very obvious nowadays. Today, we are going to focus on air filtration, which has been already mentioned. Last webinars, we were focused more on medical segment, energy, and today, air filtration. And I'm really happy that we have a speaker who are coming from industry, which is actually new to these talks, and I hope that will be very beneficial for everybody who's dealing with filters. So let's go back and give a word to our speakers. Lukáš will give short introduction to each of them first, and then the word will be given to them. Enjoy.
So as it was mentioned, today we will have speakers from the industry, from a company called Focus, which is based in Hong Kong. It's a relatively old company. Founded in 1983, and they deal basically with the production of HEPA filters until the COVID pandemic. Then they started also to focus on the production of face masks, and these face masks contained nanofibers. The first speaker will be John Hui, who is actually the production engineer in Focus. and who took an important part in the development of these face masks during the COVID pandemic. The second speaker is Mr. Teddy Miao, who is the product designer in Focus, and he's responsible for the post-processing of the nanofiber media, as well as design and assembly of the air filters. So please, I will give the word and hand it over to the first speaker, who is Mr. John Hui, and the place is yours.
Section.
And also, I have to mention that all questions can be asked in the Q&A section of the Zoom. So please type them, and then we will answer them. We will answer them at the end of the speeches.
We installed the first 1.6 meter wide Nanos Spider production line in Asia, which, yeah, is quite an investment, as we'll talk about later. So let's have a quick look of our manufacturing side. On the left is the Nanofiber Nanos Spider production line. It's also at the back as well. On the top right is the solution preparation station. Bottom right is our lamination line served as a post-production machine. Later in the webinar, we will cover the journey of installing these machines and the roles in industrializing nanofiber air filters. So, I would like to talk about the background of air filtration. There are 5 principles that how the air filtration industry works. First is draining. The simplest way to stop particles going through by physically blocking them. The second is interception. Particles are attached by fibers of the filter by electrostatic attraction force. Then is diffusion. Very small particles follow irregular paths like gas particles. They are more likely to hit and be stopped by fibers. And then is impingement. Bigger particles are not able to pass through the fibers like air does. So they are also easily stopped by fibers. Last but not least is the electrostatic attraction. Fibers are electrostatically charged, have a bigger attraction force for small sized particles. So there are numerous different types of air filter in the market. How do we differentiate them? First of all, we have different standards. For example, ISO, EN, and ANSI, so on. And there are also different sizes because many situations have to use different air filters, like motor vehicles, ventilation systems, clean rooms, isolation wards, hospitals, etc. And then we have different selection of raw material. We have metal, we have glass fiber, we have a plastic fiber, they are membrane. Some of them are light, some of them are heavy, and some of them are even washable. So regarding performance, there are a few easy to understand terms as follows. Filtration efficiency is describing how many particles are able to pass through the filter. Pressure drop is the air resistance between upstream and downstream of the filter. Dust loading capacity describes the amount of dust and particles the filter is able to bear. And finally, additional functions are those not equipped in every filter, such as antibacterial, antivirus, or VOC absorptions. Now, we'll delve into a comparison of various air filtration methods. It's important to note that while many air filters in the market represent well-developed technologies, they often come with trade-offs. For instance, filters that excel in trapping ultrafine particles typically have a high pressure drop, like glass fiber and light membrane filters. Conversely, those that are easy to clean and have low pressure drop often fall short in filtering fine and ultrafine particles, like metal mesh filters. Melblown electrostatic filters On the other hand, despite having a low pressure drop and high efficiency of ultrafine particles, lose their static charge over time, reducing the effectiveness. Nanofiber air filters, however, successfully combine many of the advantages, maintain a relatively low pressure drop without efficiency decay. Due to the time constraints, we invite you to review this detailed comparison table in the VOD later. Here are two widely used standards for air filters. MERV, which is minimum efficiency reporting value, is a standard for middle to high efficiency filters. EN1822, on the other hand, is for high and ultra low penetration air filters. These standards are used in different places and they use different particle size for testing filtration efficiency for filters according to the grades. Now, let's talk about the advantage of electrospinning air filters. The low fiber diameter leads to low pressure drop. The advantage at the average fiber diameter of nanofiber is so much lower and more consistent, resulting in higher level of porosity. This subsequently increases the dust loading capacity of the filter media. Additionally, the thinner fiber and the higher porosity also yield a lower pressure drop from the reduced acid resistance, which is important in saving energy and increasing airflow. As you can see on the picture on the left is our nanofiber taken with an SEM. On the right is the Melblown 3P with same magnification. It's really easy to identify the difference in porosity and difference in fiber diameter. So, in air filtration system, the pressure drop across a filter is a key factor in determining its performance and efficiency. The pressure drop directly influences the energy required to sustain airflow through the filter. With higher pressure drops, leading to increased electricity usage. Additionally, pressure drop serves as an important indicator of a filter's lifespan. Typically, a filter should be replaced once its pressure drop exceeds a certain level, often around 350 Pascal. Filters engineered with a lower initial pressure drop are advantageous as they generally offer a longer service life. This extended lifespan can be attributed to the lower stress placed on both the filter material and the air handling system. Consequently, such design contributes to a more sustainable and economically efficient solution. Improved indoor air quality is another benefit, as nanofiber can more effectively trap fine particles, including pollutants and allergens. The durability and efficiency of nanofiber filters lead to reduced labor and waste as well. They require less frequent replace and maintenance, which translates to both cost saving and environmental benefits. The next advantage is multifunctionality. Nanofiber air filters can be enhanced with various functional additives to equip them with specific capabilities. These include antibacterial and antiviral properties, as well as absorption of VOCs. These functions are embedded directly on the nanofibers. Compared to other methods of adding functions like coating and spraying, electrospinning provides a better coverage and less manufacturing procedures. Additionally, by meticulously adjusting the polymer solution recipe, it's possible to control morphology and properties of the nanofiber. This precise control is crucial in addressing a broad spectrum of particle size and air filtration. The ability to produce nanofiber within a specific yet diverse range of diameter is essential for the effectiveness of high-quality air filters, enabling them to efficiently target and capture a wide array of airborne particles. Traditional filters, in contrast to their nanofiber counterparts, are typically limited in functionality, primarily focusing on trapping pollutants and airborne particulates. However, they may not fully eliminate the hazards posed by these airborne pollutants. For instance, air filters used in isolation wards often accumulate bacteria. Without antibacterial measures, these trapped bacteria can proliferate on the filter surface. This presents a risk of secondary infection during the disposal of this used filter. In contrast, nanofiber filters can be imbued with additional functionalities, such as antibacterial properties, to mitigate such risk, highlighting a significant advantage over traditional air filtration technologies. Now, I would like to talk about our road to industrialization. Setting up our nanofiber air filter production line in Hong Kong brought its own challenge. The size of the facility, along with the needed equipment like air conditioning and mixing station, was quite large. In a place where space is premium and expensive, this was no small feat. Additionally, we had to consider Hong Kong's warm and humid weather, which affects how we manage air temperature and humidity in our manufacturing process. To ensure our production runs smoothly, we installed an extra air conditioning unit, keeping the environment just right for the high-quality nanofibers. So, in electrospinning, controlling the temperature and humidity is key, especially on a larger production scale. This requires a good investment in air conditioning system. With Elmarco, we've met this need by installing a specialized air conditioning unit that works alongside our production machinery. This unit keeps the air conditioned just right for electrospinning, ensuring our products are consistently high quality, and this careful management of our production environment actually plays a big role in the reliability and efficiency of what we make. Scaling up the electrospinning process of nanofiber production presents significant challenges, particularly in optimizing the recipe and parameters. The transition from laboratory scale to production scale involves difference in machine design, capacity, and operation parameters, meaning that assumption and methods effective in small-scale experiment might not necessarily be directly applicable on a larger scale. Additionally, the process of preparing solution for electrospinning is careful revision when scaled up. So, as an example, during the production scale pilot run, we encountered a specific issue where one of the additives settled at the bottom of the tank, just like the picture on the left, leading to blockage in pipes and pumps. This unexpected complication highlighted the need for adjustment in choice of additives. To resolve this, we looked for other additives that could remain evenly mixed in the solution, ensuring a smooth and consistent flow throughout the system. This change was crucial for maintaining the efficiency and reliability of the production process. And it also shows the hidden challenges involved in scaling up from laboratory to industrial scale manufacturing in our field. Secondly, stability also needs to be maintained during the continuous electrospinning process, such as airflow, voltage, current can fluctuate, affecting the final product's quality. Elmarco's Nanos Spider production line is engineered to effectively manage these challenges, offering an optimal solution for large-scale production. And then, quality control in a large-scale setup is always more complex compared to laboratory scale operations. To address this, we've integrated an online air permeability testing equipment into our production line, just as the picture in the middle. Our approach allows for real-time quality monitoring of the product, ensuring they meet our strict standards without the need to halt the production process or have to cut the substrate for testing. This system maintains high-quality output while optimizing efficiency and reduce waste. The picture on the right is one of the real-time reports generated by this online testing machine. You can see the red area is not accepted and the green area is accepted. It is much more efficient for us to have a favorable parameter or setup if we have such machine. We don't need to do testing after everything has left the machine. Finally, the quality control of raw material also plays a vital role in the electrospinning process, ensuring that the base materials are used of the highest quality and consistency. It is crucial to build nanofiber that meet our desired specifications. We believe that focusing on both the raw material and the production process is vital to producing nanofiber on a large scale, balancing efficiency, quality, and reliability. So let's talk about post-production. Transforming manufactured nanofiber into functional filter is complicated, particularly due to its fragility and thinness of the nanofiber layer. Therefore, protective measures are integrated into following stages of production process. Our lamination line perfectly avoids direct contact of the nanofiber, and the laminated layers serve multiple purposes. To make sure the nanofiber is not damaged during the process. The laminated layers also have many functions. They provide physical protection to the dedicated nanofiber layer, which prevents damage during handling and use. Furthermore, they contribute to the filter's overall effectiveness by adding different functional properties like robustity. Each layer is carefully selected to complement the nanofibers, ensuring that the final product is not only retains high filtration efficiency and also gain characteristics that are beneficial for its intended application. The lamination process is an important step in converting nanofiber material into robust and multifunctional air filter. It shows the balance between preserving the unique properties of nanofiber while ensuring the product's durability and functionality for real-world applications. But actually, barely online quality control is not reliable enough, as bypass may happen. To ensure the amount, form, and functionality of nanofiber attain our goal, fraction efficiency tests and advanced optic microscope are used as online quality control measures. Besides checking the quality of the fibers, these procedures also provide the opportunity for us to understand our nanofiber more thoroughly. So, last but not least, at Focus, we don't believe that the successful manufacturing of a product marks the end of its development. Instead, we believe that it's a continuous cycle that resonates deeply with our vision of innovation. This cycle encompasses everything from the initial hypothesis through the stages of research, trial, pilot runs, scaling up, mass production, and then on testing and gathering feedback. Each phase is crucial and interconnected, forming a comprehensive process. This continuous enhancement of product quality and functionality is imperative, not just for the success of a product, but for the growth and reputation of the brand itself. With this mindset, we now turn to the next crucial segment of our presentation, adoption. In this part, we explore how our products are embraced and utilized, an aspect as vital as the product creation itself. Now, I would like to pass my time to Teddy for the next part of the presentation.
Thank you, John. Next, I'll be talking about our experiences in commercializing nanofiber air filters. Choosing the right sector of market to compete, as discussed, the imperative step is selecting the optimal market segment for competition. This choice is pivotal as it profoundly influences the pace and direction of our product development, particularly in the electrospinning industry. For a product to resonate with a sophisticated audience, mere balancing of price and quality is not sufficient. To truly differentiate our nanofiber air filters in a competitive market, we have focused on innovation and functionality, exemplified by introducing reusable filters. This not only appeals to environmentally conscious consumers, but also addresses long-term cost effectiveness. Moreover, our collaboration with government bodies aimed at enhancing indoor air quality is not just a strategy for increased visibility. It underscores our commitment to public health and environmental responsibility, bolstering our credibility and exposure in the industry. These strategic decisions encompass 4 crucial elements: cost-effectiveness, unique features, credibility, and exposure, each carefully tailored to appeal to professionals and stakeholders in the electrospinning and air filtration industries. We also recognize that technical excellence alone doesn't guarantee market acceptance. Introducing innovative products like our advanced nanofiber filters often requires extensive efforts in education and persuasion. It's not uncommon for new technologies to face skepticism, especially when they represent a significant departure from long-established norms. We have encountered skepticism from potential customers, some of whom initially perceived our product as too good to be true. This reaction is not unusual for groundbreaking innovations, but underscores the importance of finding the right audience. Our approach has been to continuously engage with customers who appreciate the intrinsic value of our products, particularly those attuned to environmental concerns. In aligning with current global trends like ESG, which stands for Environmental, Social, and Governance, we found a receptive audience for our reusable filters among environmentally conscious groups. This alignment wasn't just about meeting basic requirements. It was about connecting with values and principles that matter deeply to these groups. By targeting clients who prioritize environmental sustainability, we could accelerate the commercialization of our product, demonstrating that it's not just about the technology itself, but about how it resonates with the values and needs of our clients. In our field, the term confidential often precedes discussion about crucial technological research, and rightly so. Safeguarding pioneering research is crucial to prevent premature replication or publication. However, as a manufacturing utilizing new technology, such as electrospun nanofibers in air filters, we also recognize that stepping into uncharted market territories entails risks. To mitigate these risks and foster market growth, we believe in the judicious sharing of knowledge and experience, much like what we are doing in this webinar. When more manufacturers adopt electrospun nanofiber technology, the market acceptance naturally broadens, attracting a more diverse customer base. This collective growth benefits the entire industry. At the same time, in 2023, our participation in over 5 local and international exhibitions has proven immensely beneficial. These events have not only been instrumental in promoting our products and identifying potential customers, but have also provided valuable interactions with researchers, fellow manufacturers, and academians in our field. These exchanges offer new insights, enhance our product development, and open doors to collaborative opportunities. Additionally, participating in conferences and talks has been a source of fresh ideas and perspectives, further enriching our understanding and approach to the market. Since initiating the production of nanofiber air filters, our journey has been marked by continuous innovation, aligning our product development not just with market trends, but also with evolving societal needs. A prime example of this was our response to the onset of the COVID-19 pandemic. The pandemic led to an unprecedented demand for face masks, driven by a shortage of traditional filtration materials like Melblown microfiber. Moreover, the face masks available at the time lacked specific antibacterial and antiviral properties, which meant that merely trapping pathogens was not sufficient to prevent secondary contamination through touching the mask. So, we swiftly pivoted to develop an advanced nanofiber face mask, incorporating antibacterial and antiviral functionalities. This development was achieved in collaboration with local manufacturers, facilitating the assembly and retail of these enhanced masks. Our efforts culminated into production of a high-quality protective face mask that was not only effective, but also innovative in its approach to filtration and pathogenic control. These masks gained significant recognition and were eventually chosen for use by the Chinese Olympic team, as well as the Hong Kong Olympic team. This development highlights our commitment to adapting our technology to meet critical health and safety needs, demonstrating the versatility and potential of nanofiber technology in various applications beyond traditional air filters. On a closing note, we would also like to showcase some of our developments in air filters outside of nanofibers and electrospinning. With our experience in the industry, we noticed that buildings create a lot of waste through the replacement of air filters. Conventional filters are thrown out entirely along with their frames, creating a lot of waste. Additionally, the filters were bulky, heavy, and difficult to handle in the tight spaces of a HVAC system. We found it quite contradicting that the usage of air filters would ultimately worsen the air quality through contributing to landfills. Thus, through much research and development, we designed a filter that features a reusable frame and a replaceable filter element. Now, while the concept sounds simple, we had to solve many issues such as ease of replacement, prevention of air bypass, maintaining the pleat distances, as well as keeping the costs down. Our final product not only largely reduces waste, but is also much smaller in footprint, as a replaceable filter media is also collapsible, saving on manufacturing, transportation, and storage costs. Combining this design with nanofibers, the final product is something that yields improvements in every facet, ranging from cost, sustainability, and performance. You can see this on the right-hand side GIF, how our reusable filter is designed. We hope you enjoyed listening to our experiences as a manufacturer in developing, mass producing, and selling a product made using electrospinning technology. And we look forward to creating even more developments together in the future. Thank you.
Okay, thank you very much for the presentation. And now we have a couple of questions here from the audience. So let's start. So one of the attendees is asking how you actually monitor the real-time deposition of the fibers, like the uniformity.
Actually, the real-time test the real-time thing is monitoring thing is only for air permeability, because this is an easier way for a running substrate. As I've shown in the PowerPoint, the graph with different colors, because air permeability is a relatively easy to measure things on moving surface. If you want to know the uniformity of the fibers, it's quite hard to have a microscope there or using light to know how uniform a nanofiber layer is. But from my experience, air permeability is also a very effective way to show how many nanofibers are on the surface or on the surface of the substrates. Yeah.
Okay, thank you very much. There is another question from audience actually asking how to optimize the electrospinning process parameters. Actually, maybe a couple of words from Elmarco's side that we usually start, let's say, to optimize anything on a product on a laboratory scale, but I can imagine if you are running the line and you want to optimize, you do it in a kind of real time. So maybe can you share, John, your experience with optimizing the electrospinning process parameters while you're already running some products?
Yeah, of course, but it's really depending on the machine that I have to use, which means that because Elmarco has great experience and insight of designing the machine with very fine and high resolution on parameters, so it's really easy to adjust to the optimized value for our air filter, nanofiber of air filter. For example, I can fine tune every parameters like voltage, like the space between the spinning electrode and the collecting electrode. These two parameters are really helpful for me to optimize the nanofiber that I need for air filtration or making further air filters.
Okay, thank you very much. Then we have a couple of questions dealing with actually packaging the already made nanofiber filters. So how do you pack the filters? That's the first question. And the second question, which deals with the same topic, is main important steps to be taken for preventing damage to the filters during unpacking, fitting, and so on. So maybe if you can answer these two questions.
Yes, of course. First of all, the machine behind me, the electrospinning machine, is mainly roll-to-roll production. So after the substrate is electrospun with nanofiber on it, it will be collected automatically by the machine, which has the nanofiber is not easily damaged during this process. So it comes to the next process, which is the post-production process. It depends highly on how well the next machine is able to protect the nanofiber with its mechanism. For our post-production machine, like lamination machine, the design of the machine avoids any contact of nanofibers and rollers in order to keep the nanofiber not damaged. Or if it's moved into another lamination machine, it has the risk of damaging because the nanofiber might touch something that would damage it. So our way to prevent it is to have tailor-made post-production machine to avoid such risks.
There is another, let's say, couple of questions dealing with some interesting topics, and that's your competitors. So how do you compare the nanofiber electrospinning technology, for example, with the Melblown, which is traditionally used for the creation of filters and face masks, and especially if you know something about the production cost differences between nanofiber, let's say, electrospinning machine and Melblown machine?
Yes, Melblown is actually a big competitor of us because it has, as I have said in the presentation earlier, it has very high filtration efficiency, even on ultrafine particles like 0.1 micron, and then it has a relatively low pressure drop. But because Melblown non-woven filtered media is usually electrostatically charged, its efficiency will be very low if it's discharged or it is just after time passes, right? And there are some standards like EN1822, as I remember. There is a part that you have to discharge the air filter first before testing. That will be a major flaw for the filter. But in terms of production costs, I think regarding the face mask, I think the production cost of Melblown fiber is very low. But back in 2019, the pandemic, or 2020, the scarcity of Melblown has posed a big problem on mass manufacturing. There are not enough production machine for Melblown. There's not enough production machine for face masks, and the scarcity made us to step into the nanofiber face mask market at the time. Hope I've answered your question well.
Wait, I'd also like to add something. It's that, like John said, the electrostatic charge will discharge over time, and that makes it unreliable for certain clients we have that request high-grade filtration efficiency, and therefore they specifically request that electrostatic charge not be used as a filtration method. Additionally, Melblown technology, there is a gap in what they can filter. So they can filter ultrafine, but then for particles slightly larger than that, the electrostatic strength is no longer strong enough to capture those particles, which nanofibers do not have the same problem of. Yeah.
Okay, thank you very much for the answers. There is some more questions actually about the quality control of the nanofiber web that you produce. So I guess this is regarding the filtration efficiency mostly. And how many meters of nanofibers do you perform quality control tests? And not only probably the filtration efficiency, I would like also to know how many times do you have to prove the nanofiber face masks are filter the viruses or bacteria? So what is the frequency of the antibacterial and antivirotic testing that you do?
Actually, for the antibacterial and antiviral testing, we follow the normal way to test these functions as other similar product in the market. For example, face mask. There's like VFE, virus filtration efficiency test, and then we have BFE, bacteria filtration efficiency test. There are also some standard tests that can test the functionality of killing bacteria and killing virus off a face mask. So we've made the filter media or even the mask itself, and we send them into labs for standard tests. So because electrospinning is a relatively consistent process, when we mix the solution, we add the agents that could kill bacteria, that could kill virus in it. From our perspective, when a small part of the product that has such function, then we suppose that every product we've made with the same solution has the same function and the same degree of killing bacteria or virus. So for the meters, how many meters do we perform quality controls? As I've introduced before, we use online and offline control strategically. Online control can keep track of the air permeability of the substrates, the nanofiber, which is correlated to the filtration efficiency. The higher it is, the higher permeable is the filter, and the lower efficiency is supposed to be. So we don't do test quality control on every meter with filtration test, it would destroy the intermediate itself. So we use online and offline tests strategically to prove that our products are good all along.
Yeah, thank you. I actually have one question for myself, and it's actually kind of frequent questions from our customers or people we are dealing with who are operating the machine. So you mentioned you are running more products. You mentioned a face mask product, but also HVAC products. So how long does it take for you in a industrial scale technology to switch, let's say, from one product to another one? In terms of days, hours, how do you deal with time switching the production from one to another product?
Wow, that's a very interesting question because, as you know, it's still air filtration for face masks, for HEPA filter, for lower grade MERV filters, or even some pre-filters. Is still air filtration. So the thing we are gonna use depends on the parameters of the machine, which is easily set, easily changed. So if I have to change from one product to another product, which is known, which I have already done manufacturing for a couple of times, then it will be just a couple of minutes to change the parameter from A to B as a recipe to get to that product. It also depends on the amount of solution or raw material I have to use, the type of the raw material as well. But these are quite manageable, I could say.
Okay, thank you. And then we have probably the last or the last before one question. What is the production capacity of the product that you produce the most? I guess I am not sure if it is the face masks or some other.
We mainly now work on filters, air filters. Face mask is still a big. On face mask, the problem is the cost is still very high comparing to Melblown face mask. The price of Melblown has dropped down quite a lot since the pandemic, the end of pandemic. Yeah. So for our air filter, the production capacity, if it's on full scale, but it also depends on the grading we produce, because we don't only produce HEPA, we don't only produce MERV rating filters. When producing these two different filters, we have different production speed. But if I really have to estimate, then it's more. I have to do some calculation first. Maybe you may ask the next question first, and I'll do some calculations.
Sure. Or you can answer the questions later on when we can.
Sure.
You all the questions, so it's not a problem.
Yeah, there were also some other questions that the participants wanted to know if there are any case studies or some real-time based studies of the nanofiber filters. I guess if you have any answer to that, it can be also answered later, probably.
Yeah, but if you can.
Or if you know already about something from your side, then you can answer it right away.
Yeah, Teddy, I think you may be more familiar with the case studies and customer testimony thing.
Studies and customer administrator.
Must repeat the question.
Yes.
Yeah, there is a question if there are any real-time based studies of the nanofiber filters, if you know about them or if you performed something in your company.
Yes, so with regard to this, we have done case studies and we have had customer testimonials as well. So one example that we've had is hotels. So air ventilation units in hotels, typically a problem for them is the buildup of mold around the air outlet units. And because our nanofibers are antimicrobial, it prevents the buildup of mold. And we've actually trialed it in a 5-star hotel. And they were greatly shocked by how well it worked, as it completely reduced all of the mold without severely affecting the amount of airflow going through their system. Additionally, it also improved their indoor air quality on top of solving their mold problem. In other cases, we found that a lot of companies are actually very interested in how nanofibers intrinsically save energy due to their lower pressure drop. And because of ESG becoming more and more important, especially in Hong Kong, a lot of buildings are willing to try a new product just based purely on the fact that it saves electricity.
Okay, so that was our last question for today. So we would like to thank you, Mr. Speakers, both of you.
Thank you very much.
Yeah, definitely. And thank you for all you following us, because we really appreciate it, and really, again, invite you for the next session, which is 23rd of January. Thank you. And we will definitely get in touch, contact you with the speaker later on if there are some questions which hasn't been answered. Thank you again, and have a good day.
Thank you.
Thank you.
Thank you again, and hope you guys enjoy our webinar session.
Okay, goodbye.
Bye.